All right, thank you all for coming. Who here likes privacy? Hey, that's everybody. Do you like blockchains too? Yeah, okay, well, they don't really go together very well. But I think that's changing, right? We're seeing some really cool new technologies coming about. It's been floating around a bunch, this like ZK thing or whatever. So I want to tell you about a little work that I'm using with some of the modern programmable cryptography that's out there and plugging it into Celestia to make privacy and blockchains work together. So like today, data availability is really important. We've heard already some really cool use cases for how you might want to use it. Like the safety and liveness guarantees is great, but it's all public, man. Like that's not necessarily what you need for sensitive applications. Even today we're hearing about a few like Hibachi, for example, that we're working with on this particular project. The data is sensitive. Like you want to be able to control who has access to this stuff, not just the whole wide world, right? And so really we want private data availability. So the data is definitely available and it has the same kind of guarantees to be able to have that data that you might on Celestia, for example, but you want to selectively disclose in some programmatic way, right? You want to be able to constrain who can actually view and operate on this data, even though everyone can have access to a private version of it, right? So today's encryption, unfortunately, you'd be like, oh yeah, just encrypt it and like throw it on Celestia, right? That works, yes. But it doesn't reveal anything, if it's any good encryption, about what you actually encrypted, right? You can't prove to anybody that, hey, well, inside of this encrypted data there is something, or it has some particular properties. You gotta fully trust whoever is encrypting this data that they encrypted it correctly, and in fact, whatever they said they encrypted is the thing they actually did, because it should tell you nothing about it by observing this, the ciphertext, as they call it in the industry, right? So verifiable encryption is this new method, right, that allows us to verify claims on what is inside of encrypted data, right, without the ability to decrypt it. So this is important because now we can have privacy, but also prove to you that indeed there is something hidden in this information that if you were able to decrypt it, it would have some properties about it, right? So this constraints on the encryption that you're doing, we're able to prove, for example, what algorithm you used to encrypt this data, what keys were used, or what keys could potentially be used to encrypt and or decrypt this data, as well as what are the properties of the actual data that is enclosed inside of this little private envelope, right? This provides a way, private data availability, to anchor verifiable encryption into whatever your protocol is doing. So if you need to know that some data is available, but isn't public, but you can retrieve it and potentially throw some decryption algorithms on top of it, programmable as you see fit. This provides this for you, right? So what are some use cases? Like, I've been thinking about this for a little bit, and I've got a couple to show you, but I really want to hear your ideas. So Q&A session after, but also like, throw me your crazy ideas how we might be able to use privacy on DA. So I think in general, if you want to build any dApp with any kind of privacy, now we can do collaborative but permissioned applications using these anchors. So we know that this particular application needs this particular data to operate on and control who is able to see it, even though the data is existing on a public network, which is pretty cool. It's inspired a lot by, I don't know if anybody here follows Ink and Switch. Is that a name that some people know? No, you should. I'll share a link to this afterwards. That's a link for the local first access control. Some really interesting research about encrypted data at rest and permissions to be able to sync data across the network, it's like DA being your backend, but permissionlessly control who's able to have this. Cool. So some examples that I've been thinking about, private rollups or rollapps, right? If you want to have potentially partial obfuscation of what's going on inside, this is definitely now possible. You can wrap potentially the entire state of whatever it might be, of your favorite rollup application, your kit, SDK, whatever it might be, so that anything that is posted about this really can be, again, permissioned as to who can have access. It could be everybody or it could be nobody. It could be parts of the state that you're using, whatever you'd like. Verifiable backups. We heard a little bit earlier today from Hibachi. I think that this is kind of a general class that I'm really excited about, is that, no, I won't give you the data, sir, but I can prove to you that it is available such that in whatever scenario we've decided, these keys will be recoverable and you can get access to it, right? it is the data you need. Not just, trust me, bro, it's the data, like, I promise you'll get it. It's definitely there. And one of my, I think, reasons that I came to Celestia at all is inspired by this idea of trustless data markets. So if you've got some data and you want to be able to prove that I'll sell it to you without a third-party intermediary providing that trust, how can we go about doing that? So to give you a vague sense of how this was a hackathon project about a year ago that somebody put together, you're able to take, for example, a photo, right, and encrypt this photo such that you can now put it on a data availability layer like Celestia and link this to an escrow contract that says, hey, look, if you pay me money, right, this encrypted object that's now available on Celestia that I don't have control over anymore can be decrypted by you. So you can enable logic that will be a trustless auction, right, for whoever wants to buy this image, right? They also had a second stage where they're able to do provable thumbnail, so you're able to do a very low-res version of this to prove that, in fact, this thing that you're looking at that's not so great, there's like, you know, a super HD version of it that I'm actually selling you, right? So it's kind of cool. So if you want to use this today, as of now, I think Hibachi is hooking up to this. We have a private DA proxy. So all your favorite APIs that you use with Celestia today work out of the box, no modifications needed. We intercept and do this verifiable encryption step for you and post to Celestia, and you can pull it back and decrypt it in transit. So to you, it just looks like normal Celestia. To everybody else, it's a black box. So we can get into the technicals if you'd like, but I think it's one important point to notice that this is parallelizable. So whatever you're doing with your operations, you don't necessarily have to be blocking on publishing of this information. You can do this verifiable encryption step, which at least today is a little bit not super performant. It might be a bottleneck in performance for you, so we can do it in parallel. Post it later. Future directions. That bottleneck, I think, is a temporary one. There's some really cool things thinking about hybrid ways that we can use T's, MPC protocols, and other novel ZKP things, as well as just the whole industry is getting more performant overall to make this significantly better, as well as something that you can outsource. Potentially, if this is something that everybody would like, something we can embed and really enshrine into Celestia itself to provide the availability to have a privacy switch on whatever you're posting. So that's it. If you want the slides, they're there. And I'm open for what ideas you have for private data availability. Cool, thanks.
Are you giving like a hash of the proof, or how are you able to verify in the exact same API that you guys actually encrypted it before it got posted to the chain? So like in the case that it like doesn't post, or, well, doesn't post is easy, but like if it encrypts it incorrectly, how can we verify that?
So encryption incorrectly. We're running the encryption algorithm completely right now inside of a zero-knowledge virtual machine. So essentially, you're able to prove the execution of the encryption algorithm itself. So we know that that's correct. If you got bugs in your software, well, that's a different problem. But what we're able to attest to is essentially this verifiable encryption object, which has this hash of the key that you used, implicitly the algorithm, because you're able to validate only for the program that you ran, a hash of the input data, and finally the ciphertext itself. This is all then sealed and attested to by a Groth16 proof. So I don't know if that answers your question fully, or?
Yep, that helps. Thanks.
I think a cool app will be to use for private DA is a unstoppable AMA session where only people who paid me a lot of money can decrypt my answers. Thus, Eric Wall will finally stop, you know, shitposting and go back to doing the orbs.
I like it. I like it. All right. Well then, thank you very much, and yeah, feel free to check out the code, and we'll see you later.